Hey there, John Davis here with Paul Davis Automation and 3ML LLC. Figured I would post a quick video on what I think is a better way to read the I/O values off of an Arduino Yun. I had messed around with trying to get the values processed through the bridge. You can instantiate bridge in the Arduino software and try to pass values over the serial and blah blah blah. It's just a pain. So I figured I would do it a little bit of what I think is a better way. It's a little bit hackish, but you know what? Sometimes hacks are the best things that get all this stuff done here. So real quick, what I'm doing is I am using my demo kit over here that I put together with my stepper motor. It's an AMCI SMD series motor. It's a Modbus TCP integrated industrial stepper motor. And I've got an analog pot, and it's an analog pot with a 10K ohm resistor on it, and it's just a simple back and forth switch. And basically, I want to be able to control this motor going back and forth with this analog switch and the rotary pot. So I need to take those values and get them into the Arduino, and this is kind of how I'm doing that. So kind of the trick here with this whole thing, go back to the Arduino screen, is I'm taking the values out of the inputs and actually putting them into a file on the Linux file system. So I'm bypassing trying to pass values over the bridge or do anything crazy like that. I'm just using simple Linux shell commands to take these values and dump them into a file. So when I start up here, I do some housework just to get the network set up and everything, and then I use the Linux touch command to basically make a file called smd underscore manual underscore values in the temp directory. And once I do that in the loop here for the Arduino, I'm basically just echoing some values. So put the string together, the command string, it's echo whatever the jog direction is, comma, whatever the pot value is, and then using standard direction on the Linux command prompt to dump it into the file. So if you remember your Linux commands, just using one greater than symbol like that basically just takes the value and overwrites it, overwrites the file, overwrites the contents of the file rather, with whatever the value is that you're echoing into it. So once I create that command string, then I use the process function in Arduino here, which does use the bridge, and basically I tell it to run my shell command. So it's very, very straightforward. There's no messing around with the bridge serial connection and how to communicate with it over Linux. It seems to be a common sticking point for Arduino Yun users here. So yeah, this makes this thing very, very, very straightforward. So this runs through the loop. There's a 1 millisecond delay in the loop there, and basically I'm just going echo values, echo values, echo values. And the end result of that is, back on this screen, I'm SSH'd into the Yun over here. If I tail that value, or I'm sorry, that file, temp smd manual values, you can see there it's at 1 and 0. So we can actually see this thing change in real time, which, by the way, actually before we do that, let's take a look at system load with this. Bridge.py is not the most efficient, I guess, program on the planet. So the one downside of this is that I'm using about 31% of CPU just sitting there writing on the bridge. But you know what? As you'll see later on when I actually move this thing, it doesn't seem to slow things down too much. So so it's not bad. But anyways, going back to here, so we can tail that and we see some values. If we do a little bit of bash scripting, let's see here, cat temp smd, oops, put a do in here, do cat temp smd manual values, done. That'll give us a readout here, and as I rotate the pot, you can see the pot values are changing. And if I change the selector switch, got some values there. You can see it's pretty quick. You can hear the switch switching in the background there. It's not bad. It's actually doing the thing pretty quickly. So all things considered, that's actually not a bad way to get analog data out of the Arduino. Now, what does this actually look like? Well, let's take a look here. So if on this other side here, on this other split screen, the way I architected this server was I just set up a simple socket server in C here, and whoops, sorry. And basically I had it listed on port 7000, so any client that connects to it, I showed in an earlier video, I made an iPhone client that'll connect to it and pass it string commands, but anybody can connect to it and pass it the commands. They're very simple ASCII commands here. So if I, let's see here, do we know that local on port 7000, we should connect. There we go. And this is the command that let me see, 10.6. Believe that is the motor IP. Let's see if I'm right. There we go. Okay, so now I'm connected to the motor, which I'll pop up here on the other screen here on the side so you can actually see it, but connected to the motor. And then if I issue this command, make sure my pot's at 0, that actually tells it to go into manual mode. Well, that's about all I've got. Hopefully you learned something and had fun watching this video. If you have any questions or want to pick my brain on anything, you can always email me at jd@pauldavisautomation.com or find me on Twitter at JohnPRDavis. Other than that, happy hacking, have fun with your projects, and talk to you soon.